start talking about shortcuts to triangle congruence. It's been relatively inconvenient for us to prove triangles congruent because we have to show all 6 corresponding parts, all 6 pairs are congruent. So we're going to come up with some shortcuts for triangle congruence, and we're going to start with the side angle side shortcut, SAS we call it. And usually this can just be abbreviated using the SAS. Basically what has to happen is I have to have 2 pairs of sides congruent in 2 triangles. So I've got BA here congruent to DE, and I've got CA congruent to DF. That's fantastic. But then I need to have the angle that connects those 2 sides also be congruent. So it has to be in the order side, angle, side. It can't be side, side, angle. It's got to be the angle between the sides. And when that's true, then we have congruent triangles. And the reason why we have them is my congruence theorem, which is side, angle, side. We're going to write a proof. Oh dear, writing a proof. Yep, we're back to doing that again. We're going to be doing that a little bit in this chapter, and it's important to get the practice. So let's dive right in. Our proofs are 2-column variety. And let's start with what we're given. We're given BC is congruent to DA. That's given. Now, that's given in the givens. Is there anything else given in the picture? Well, yeah, we have BC is parallel to AD. Now, you're probably thinking to yourself, well, how does that help me? How does that help me to have a side parallel to another side? Well, what do parallel lines give us when they're crossed by transversal? Yeah, they give us congruent angles. And here, I have a pretty clear Z in a parallelogram with a diagonal. Since we're told those sides are congruent, or are parallel and congruent, I can conclude now that the alternate interior angles, angle BCA, must be congruent to angle CAD. And the reason is alternate, oh, this is also given, by the way. Alternate interior angles. Alternate interior angles theorem tells us that. Tells if 2 parallel lines are crossed by transversal and their alternate interior angles are congruent. I told you this stuff from chapter 3 was going to keep coming back. Here it is. All right, so I've got a pair of congruent angles. I've got a pair of congruent sides. I've got a pair of parallel sides. Do I have my other sides congruent? Is BA parallel to or congruent to CD? Well, let's look at this. BA and CD are connected by this transversal. I do have a Z there, but can I use alternate interior angles theorem here? The answer is kind of obviously no. Why not? Because I do not know that these sides are parallel. If I had that, I could do that. But so that's the reason to always draw on your picture. Make sure you understand what you're doing. Make sure you're catching the parallel sides and not the non-parallel sides. Last thing we have is something we haven't really done before, and that is look at this idea of CA. CA is what we call a shared side in the triangle. In other words, it's a side in both triangles. And I need to say that it's congruent to itself. Now you're saying, well, obviously it's congruent to itself. Anything's congruent to itself. It's equal to itself. That's true, but it's in 2 different triangles. So we're using it in 2 different ways, one for the upper left, one for the lower right, so I have to state it. CA is congruent to CA, and that's reflexive property. Now I look over my proof. I have 1 pair of congruent sides. I have 1 pair of congruent angles. I have another pair of congruent sides. They are indeed in the correct order. Side, angle, side. Therefore, I must have triangle ABC congruent to triangle CDA. And my reason, side, angle, side. Because the angle is between the sides. It's that way in the picture, it's that way in the theorem. Side, angle, side. We're going to get plenty of chance to practice this. You're certainly welcome to go back, rewind this, and look at it again. See if it helps. In this diagram, QS and RP pass through the center M of the circle. So QS and MP and RP, both pass through M. What kind of shape does that make them? A segment that passes through the center but has endpoints on the circle is a diameter of the circle. And MP, MQ, MR, and MS are all what? You're right, those are radii of the circle. Each one is a radius. So I know, for example, since the radius of a circle is a constant, that these two are congruent and that those two are congruent. What else do I need to prove congruent triangles? What can I conclude? Well, if I have two pairs of congruent sides, I need their included angles congruent. And will they be? Yes, because they are vertical angles. Angle SMR is congruent to angle QMP because they are vertical angles. That's another one of our special conclusions. There are basically two things we look for in these triangle proofs. We look for shared sides, we look for vertical angles, and we'll try to utilize those as facts from the picture in many cases. So please keep your eye out for that. Notice our strategy, too, in completing the proof. Back here. We prove corresponding parts congruent and build up enough parts to get to our shortcut side angle side. I can't jump straight to side angle side. I got to build the individual pairs of parts first. Here, ABCD is a square with 4 congruent sides and 4 right angles. I don't know what other kind of square you'd have, but let's just put it out there to be sure. R, S, T, and U are the midpoints of each side, and RT is perpendicular to SU. And SV equals VU. So this is congruent to this. That's a right angle. These are the midpoints of each side, so this is congruent to this. This is congruent to this. Sorry, it's supposed to be 3. Okay. So actually it's 4 again and 5 there. So we'll just call that V and V. Okay. Those are all congruent parts. But what do we know? We know that it's a square, so that means all 4 sides are the same. So that means actually all of these little segments here are exactly the same, as are these 4. Do I have enough to prove that SVR is congruent to UVR? Again, let's notice that where that is. SVR. Sorry. SVR is right there. And UVR is right here. Are those going to have to be congruent triangles? Absolutely, because the side had told it's a right angle congruent, so this is a right angle, this is a right angle. So side, angle, side, side, angle, side. They are congruent. I'm not going to write the whole thing out, but that's basically how we go about it. Finally, you want to make a sign to hang in a triangular position on the barn wall shown in the picture. You think you can use 2 identical sheets of canvas. You know that RP is perpendicular to QS. Use side angle side to show that PQR is congruent to PSR, triangles. So P is the midpoint. We know that because we got these marks here. These 2 are congruent. I know this is a right angle. This is also a right angle. And what's the other thing I have? The other thing I have is a shared side, RP. So do I have enough information to show they're congruent triangles? Absolutely. Okay. So how do we prove that? Well, a little bit tricky, but not too bad. Start with our given, PQ congruent to PS given. We're also given that RP is perpendicular to QS. Now, how do we get from perpendicular to right angles? Two pairs of right angles. Well, we know that if a pair of lines is perpendicular, they intersect to form four right angles. So, we know that angle RPQ and angle RPS are right angles. Okay, we get that from the fact that it's perpendicular. Definition of perpendicular. Next, what do we know about right angles? We know that all right angles are congruent. So angle RPQ is congruent to angle RPS because all right angles are congruent. That's a little bit tricky, but oftentimes we see perpendicular lines, we need to prove congruence, that's what we do. Finally, we have, so I've got a pair of congruent sides, I have a pair of congruent angles. Now what else do we have in the picture? So we take our givens from the instructions, and we make what conclusions we can until we can conclude corresponding parts congruent. So the first one was directly a corresponding part. The second one required 3 steps till we got to congruent angles, but we used what was given to do that. Next, we look to the picture. What is the picture giving us? The picture is giving us that RG is congruent to itself. And whenever we say something is congruent to itself, that is reflexive property. So there's my final side. And now I do indeed have side angle sides. So triangle, if you're wondering about the order we should write it in the same order that they gave it to us in PQR. It's going to be triangle PSR. And so far, the only choice I have for shortcuts is side angle side. So we ought to be looking for that. All right, that's kind of a longer lesson. It's going to take some extra practice from some of the other stuff. So by all means, come to class ready to work, ready to ask questions, and we will dive right in. See you in class.